All right, day 3, properties of functions continued. Recall of the function machine, we talked about this. And then here at the bottom, the function is like a machine. When you enter a single input value from the domain, okay, x coming from the domain, the machine produces a single output that lives in the range, as determined by the rule of the function. This is symbolized like this in mathematics. So let me draw it for you. You draw an oval. This is the domain. You take any one of many inputs. So this is like x1 and x2 and x3 and all these other x's. We'll just show it for one. You take this x and you apply the function, and then you get this new value that lives in the range called y. Okay, this is how it's visualized. Some value in x, you apply a function, and now it's some value y. And we can call that one y1, I guess. x1 to y1. And then that ordered pair would be x1 comma y1. That would be the ordered pair. Those are ones, my bad. So I'll draw the comma a bit better. x1 comma y1. That's the ordered pair for this relation. Now the function has other names. So you can think of the function, another word for it is like a mapping. That's basically the two words, a function or a mapping. Do you guys remember in elementary school or junior high like doing like reflections and translations and stuff? Yeah, so what ends up happening is when you get to math 30, you'll be doing function mapping, which does like translations, flips, rotations, all these things, but with actual equations and how the algebra relates to those function mappings. Okay, now all functions are relations, but not all relations are functions. Okay, demonstrated by this Venn diagram. So if you're a function, you're a relation, but not all relations are functions. I believe that was in the homework last night, if you did your homework. All right, now this one, function notation, was also in the homework. It was kind of a weird question. A couple students asked me about it, so hopefully you saw it. But we use this notation, and what is notation? It's just how you write something, okay? And if students don't study this, it becomes really apparent that they don't understand what's going on. Okay? Now this symbol here, f at x, or f of x, that's how you read it. F at x or f of x means you're going to input x into the function and it's going to output some y. So look at this right here. What this tells us is that f at x is just another way of writing y. F at x is the y component. So there's basically two ways to write it. The xy notation and the function notation. Most of the time when we're working with functions, we live in this xy notation most of the time. But occasionally you'll be given this notation as well. And both are pretty normal in a math classroom. This is what it looks like graphically. The function is just the curve. This is the function, the curve, the graph. So for some x, there's some y that goes with it. For some x, you apply the function at x and you get the y coordinate. So f at x is just the y. Okay? So here we go. Here's some function. Here's some function. And we're going to do this algebraically. And we're going to calculate a bunch of different examples related to this function. So this first page, I want you to highlight this one here. In this page, we're given the input. So in other words, i.e., the x is known. So solve for y. That's what we're doing on this page here. All right, so the first two are pretty normal and simple. Actually, the first, yeah, other than E and F, these are pretty straightforward. So let's do A, B, C, and D together. What does this say? F of 2, good. Someone else, what does this one say? What? F at 0, good. So Sean said F of 2, and yeah, that's okay. And another guy says F at 0, that's okay. Okay? Yeah, however you like it. Now look up in the equation. What does it say the function is? We're gonna take that x, and what are we gonna do? We're gonna square it, we're gonna times it by 2, and then we're gonna add it, and then we're just gonna subtract 5. Okay? So what happens if we plug in a 2? What will this look like? I would start with just doing this. And especially if you studied and did well in the last unit with polynomials, this is probably no issue for you. What are you doing? You're just evaluating the polynomial when x is 2. And this is going to output some y value. So what do I put in those brackets? 2. So use brackets to substitute. That's a good strategy to take with you for the rest of the time that you do algebra. Just use brackets to substitute. It's probably the best way. And then at this point, you have to think order of operations, like you did in elementary and junior high. What do you got to do first? Brackets, but there aren't any. Exponents, yeah, exponents. You have to do those exponents first. So what's 2 squared? 4. And then what do we do next? Multiplication. And you still get 8 plus 2 minus 5, and then this is just 10 minus 5, which is 5. So what does this, like what does this tell us? What does this mean? It tells us that when x is 2, the y is 5. Okay? That would be the ordered pair. This is the ordered pair on the graph. That's all it means. It means if you went to find 2, you would have to go horizontally 2 to the right, and then you would go 5 up, and that would be a point on this graph. The next one's gorgeous because the x is 0. This is like the most lovely thing ever. Like, what's the answer to this guy? 0 squared is 0. 0 times 2 is 0. 0 plus 0, 0. And then you're just left with negative 5, not 5. Okay, so then the ordered pair would be 0, comma, negative 5. This one's actually an interesting point because where would it live? Would it live in a quadrant or would it live on an axis? Yeah, this one lives on an axis. And we call this one the y-intercept. We'll come back to this later, but it's just nice to see things more than once. The y-intercept. I wonder why it's so called the y-intercept. I'll draw it on the whiteboard for you. Where would this point be? 0, comma, negative 5. So whatever this graph does, might do something like this. Who knows? But that's the point that's on the y-intercept, on the y-axis. Okay, now the next one is put there on purpose because it's negative. And this is a very common mistake. So first we'll substitute. Okay, so what do I put in those brackets? Say that again. Negative 3, good. Okay, so put in negative 3. That's the input. And then I'm just going to show you this right here. Like, it's going to go like, bring up the calculator here. because I know a lot of you like to refer to the calculator, so just quickly put it up. So we have to do those exponents first. So negative 3 squared, look at this. Ooh. What just happened on that calculator? Good. Good, 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 good. See, this is one of the most common mistakes for young people doing math. This negative 3 squared is actually not negative 3 squared. It's positive 3 squared. What's positive 3 squared? 9. And then it's multiplied by a coefficient of negative 1. To properly do this, what would you need? Yeah, a bracket. So you're telling the calculator it's negative 3 that's being squared. See the difference? Now actually check out how nice this calculator is. If you just sub in with brackets every single thing, like, and just copy down how you wrote it with the substitution with brackets, it just does it for you. So, I mean, you see how you can just do that? So that's a nice little strategy, especially if your mental math isn't quite, you know, if you're not too confident in your mental math. Okay, so I'll just do it by hand really quickly so you can see it. So we should get 10. So 2 times 9 plus a negative 3 and then take away 5. So this is 18, take away 8, which is 10, just like we said. Are you guys okay with the negative 8 here? Because you're basically combining a negative 3 and a negative 5. It's like you owe 3, you owe 5, altogether you owe 8. And then it's 2 times 9, 18, take away 8, which is 10, just like the calculator told us. Now, of course, there's one with a fraction, just to make you guys happy. I know everybody loves them. So substituting in with brackets. Okay, so let's take a look. Like before, you got to do the exponents first. What's 1/2 squared? It'd be 1 squared over 2 squared. Do you guys remember that from the exponent laws? You have to just put the power 2 on both. Okay, so then you get 1/4. Okay, what's twice a quarter? You have 2 quarters in your pocket. How much money you got? You have 50 cents, right? 2 quarters is exactly 2 quarters. The 2 times 1 is 2. 2 over 4 is, what is it? 1/2. Good, 50 cents. So you have 1/2 plus 1/2 minus 5. Could you do a half plus a half? Half plus a half is 1. 1 minus 5 is negative 4. Now, ultimately, if this was like a test situation, you could do that in your calculator, but it's nice to just practice these fraction operations by hand. Do you have a question? Oh, if x is a half, the y will be negative 4. Yeah. Okay, so for this one, you can put the ordered pair on the side here. Negative, or pardon me, 1/2, comma, negative 4. That would be the ordered pair. All right, now comes the mostly just algebraic kind of fun here. Like what happens when you put in an expression? What happens if you put an expression into the function? Okay, so copying from above, you have a bracket, it's got to be squared, plus a bracket, and then take away 5. So what goes in those brackets? 2a. All right, so now we have to do the exponents first. How do we apply this exponent to this product? The 2 has to be squared and the a has to be squared. So you get 4a squared. Okay, plus a 2a, take away 5. So when you get 8a squared, just because 2 times 4, plus 2a, take away 5, and then that's it. Okay, so if you input an expression, output an expression. All those other examples we did, we were inputting numbers and we were outputting numbers. So in this one, because we're not inputting a number, we're inputting an expression, we output the expression. And then the last one's just more difficult. So use the original equation. 2 times bracket, we have to square whatever's in that bracket, plus the bracket, take away 5. So what goes in that bracket? 3y take away 1. And then this is where like math from last unit is now going to be in play in this unit. What do we have to do here with the binomial being squared? Yeah, you got to write it twice, and you're going to have to do what with that? FOIL, right? So leave the 2 on the outside for now. We got a 9y squared. 3 times 3 and y times y. Take away 3y on the outside. Take away 3y on the inside. And then on the last is a positive 1. All I've done in this step is the FOIL, which for the most part, I would say about 70% of you are having no issues with foiling after marking your last exam. However, on that last question in the exam where there was like multiple terms, when you have to like use foiling in like a unique way, there was some drop off. Less of you had success. Okay, we still have the outside. So we can actually simplify these two. A -1 and a -5 is just -6. You can collect like terms out there. And again, we can collect like terms right here. We can put those together for -6y. That way we don't have to rewrite this entire line. So when we scale in this 2 onto each term, we'll have 18y squared minus 12y plus 2, and then plus the 3y minus 6 on the outside. So all I've done here is just doubled everything, because that's all it is. There's a 2 on the outside. It's just doubling each one. 9 goes to 18, 6 goes to 12, and 1 goes to 2. Once you're done expanding, you see I've been expanding for 2 lines. Once I'm finished expanding, there's no longer any brackets. Also up here, top right, like because there's like a 1 out here, and you're like essentially expanding in a 1, which doesn't change anything, you can drop those brackets. You can drop those brackets there because you're just adding and then collect like terms up there. Now last step, we just collect the like terms. There's only one term having a y square, so that's done. We have 2 terms with y. That becomes -9, a -12, and a +3. And then the last is just the constant, a +2 and a negative 6 gives negative 4. So that's it. Just like in the last example, if you input an expression, you output an expression. If you think like you want to take the -1 stream, like you got to be good at this kind of stuff, because the -1 stream is heavily invested in algebra. If this is scary to you and you don't want it as part of your life, like, and you're not willing to work at it, the -1 stream will be a challenge for you. Okay, so this is more in the 20-1 kind of stuff. Whereas these, like if you were okay with these ones, like this is more the -2 route. Like you're still doing the same kind of idea, but it's just less algebraic in a sense. All right. On that last page, do you guys remember we highlighted given the input? So on this next page, we're going to be given the output, okay? So you can highlight this on the next page. Okay, given the output. Okay, so on the last page, we were given the x and we were finding the y. Here, we're given the y and we're finding the x. Okay, so you can jot that down. Given y, find x. Okay, this one involves those 1 and 2 step equations. Okay, so let's take a look at part A. If the function is denoted by f at x, 5x take away 7, then let's find the value of x if f at x is 43. What this actually means is the y is 43. So definitely put that. Because sometimes students look at this f at x and they're like, I don't even know what that is. What does that mean? It's just the y. Okay? That's pretty good. It is 10. That's pretty good. So what we do is we substitute this entire thing for 43. Okay? It's pretty good. So, listen up. Donald, can you put your hood back, please? So, you see how this f at x is equal to 43? We can replace this f at x symbol with 43. You guys okay with that? It's just a replacement. This f at x symbol is replaced with 43 because f at x is 43. So it's just a substitution. And then this is something you guys have been doing for a couple years now since junior high. This is a two-step equation. What do you move first? With the opposite. Like what's the opposite of -7? +7. Okay, so let's throw that in there. And you know, sometimes this might help you. It's like draw a vertical line down the equality to help you keep the things balanced. So then you get 50 on the left and 5x on the right. Now think about this expression. 5 times some number gives you 50. That number has got to be 10. Good. What is the last step, though, if you wanted to do this? Divide each side by 5. You always divide by the coefficient. Okay, why don't you guys try a second one here, rather than me doing it. Okay, try the second one here. Kiara, you with us? Okay, so you throw in the -24. Now, how do you move the 3 to the other side? Yeah, well, we can think of this +3. Like, if I want to move it to the other side, I would just put a minus 3 here. Okay, you can imagine this plus 3 like being picked up and moved over to this side, and you just have to switch the sign. It's the same thing as going like minus 3 on both sides. So then on the left, you got a negative 27, and on the right, you have 6x. Because 27 is not a factor of 6, you're going to get a fractional value. That's okay. Okay, 27 over 6 is the x. For sure it is. And you can reduce that fraction. They both divide by 3. They both divide by 3, so you get... pardon me, they both divide by 3. You get negative 9 over 2, which is negative 4.5. Okay, negative 4.5. So what that means is when the y is negative 24, the x is negative 4.5. So as you can see, we got a fractional value. So is this discrete or continuous? You had it. If you get these fractional values, then it's continuous. So you can put this here. All equations are continuous. Okay? Sometimes you get that question like, is this function continuous or discrete? If you have an equation, it's definitely continuous. Because you could put in any value you want. Okay, so I'll let you guys do the rest of these on your own. So finish these 3 questions and then do this assignment. And then in about 10 minutes, I'll put up the answers to those 3.